Is this thing on? Hi, Poland. My name is Andrey. This is Arpad. We came from Berlin, from Zalando, where we implemented our own take on front-end microservices. First, a little bit about the company. So we are an online fashion store, and recently we've been scaling a lot, and we needed to hire more people, and the existing infrastructure didn't scale. So that's why we came with a set of principles, and one of such principles was team autonomy. So team autonomy means that team is like a small company inside the company, like a small startup, and team is free to make their own decisions. So they can decide on their own processes, they can decide on their own technology, and they decide on how they want to deploy and operate their services. But in reality, what we had at that time, and it's currently there too, we have a huge shop monolith that is a very large Java application that takes a long to compile, and it has a lot of dependencies on the staging environment. So, for example, if some service is down, you cannot start the shop, so you have to wait until the problem is fixed. It has a lot of people contributing to the same code base, and many different teams are working together with the same code base. So sometimes when one team settles a bug, then everyone has to wait for them to fix the bug, so shop cannot be deployed while they are fixing it. So this postpones features and bug fixes and so on. So this ends up in a slow release cycle. And the state of the front end there is terrible, so it uses JSPs to render, and it has a little bit jQuery, a little bit Backbone, some CoffeeScript, less CSS. Well, you can study front-end archaeology there. We were put together into a task force, and our mission was to deliver the promise of the team autonomy. So we had to basically identify the architecture and develop core components of this architecture. And then, of course, we had to and still have to support the transition, because it cannot be done as like big bang rewrite. So we had to, Dream has to be there in place along with the new architecture, and everything has to work all together at the same time. So in the end, what our mission was is like to put Jimmy to rest. So we had to tear it apart into microservices, and then build the website on top of the microservices. Then we thought, so what if we could have something similar to backend microservices, but on the front end? Like, is this possible? And so we kind of defined what we want our microservice to be like. So we call it a fragment. So a fragment is an independent web server, just as a backend microservice, and it renders only the part of the page, and it is responsible for its own JavaScript and its own CSS. So in this case, there needs to be a composition layer that composes the page from such fragments. And such composition should have this list of requirements. So basically it has to compose pre-rendered markup on the backend, which is important for search engines because we are online fashion store, so we really depend, I guess, on Google. And it's also quite important for mobile devices that are low CPU, so it's better to deliver the markup there so the users will see it immediately. We also have to ensure backend and frontend performance. So backend performance is basically time to first byte, and on the frontend we need the users to be able to see some content immediately as soon as possible. And as well, in the area of microservices, we have to be fault tolerant because if some microservice is down, then we should still be able to render some meaningful content to the users. And the last problem that was also discussed in the previous talk, that we have to somehow enforce the same look and feel, because if each fragment is owned by different team and they don't really communicate with each other, they're independent, and yeah, you can end up with a soup on the front end, so different kinds of buttons and so on. And this is how our layout service was born. It's called Tailor, and it does just this. So it fulfills this set of requirements and composes content on the backend. So let's go into details what it does. So first, when it gets the request, it gets the template for this request. Then the template is like HTML-like markup. It parses the template, it finds fragment tags, then it calls all the fragments, and it assembles the streams from the fragment into a single output stream. So it uses streams a lot in order to be performant. And when it knows when to output, it sets response code, and then it starts streaming the output into the browser. So this is how the page template looks like, and this is an actual page that you can see if you go to like Zalando PL/cart. So here you see that we have header, we have cart, we have footer, and the template looks almost like this. So on top we have base assets, that is like a set of common dependencies. Then some fragments are not visible, such as tracking. And recommendation is not here because it's an empty cart. And then besides that, the cart fragment has a fallback SRC defined, so in case cart fails, there will be something different rendered instead of it. And two bottom fragments, they are denoted as async, and what this means is that instead of rendering the output immediately, it just streams the placeholder, and then in the end of the body tag, when the content arrives, it comes along with the JavaScript that puts it back into this placeholder, while the page is just being assembled. And the whole thing allows us to have progressive rendering of the page. So page load may look like this. You'll see the header, then the cart, and then comes the footer. And so because we are using streams, so the content may come later. So some, for example, the header may be visible, and the cart is still calling all the microservices behind it in order to render the cart page. So we are not waiting for it, and the user immediately sees the header. At the same time, we achieved quite fast time to first byte, because in case of the cart page, we don't care what is the response code of the page, so we don't have any so-called primary fragment on the page, and we can respond immediately with 200 and start rendering the page. In this case, part of the fixed markup of the page will be already in the browser, while another part of the page is still being rendered. So these are the attributes of the fragment tag. So I guess here it's important to say about the primary fragment, because in some cases you do need to set response code of the page based on the data. So for example, if it's a product page and the product is not found, then you should set 44 so the search engine will not index this page. Or you may need to do a redirect, and this logic should belong to the primary fragment. There may be only one primary fragment. And here how the magic happens on the front end. So just before the very first fragment, whenever it is on the page, Taylor injects the following code that is required.js or like any AMD loader, and then goes the magic pipe class. So our idea for progressive rendering was inspired by Facebook's Big Pipe, but what we have is something different. However, we choose to keep the name. So it's initiated, and the instance name is always random, just in case. So when the fragment is flashed into the output stream, it turns into this code. So we put in line link to its CSS. It has to go before the fragment because you want the style to be there when you show the markup. Otherwise, you'll see a flash of unstyled content. Then goes the start, and then this 3 dot, they denote the content of the fragment, the output that is returned by the fragment server, and then end. So yeah, so the magic happens in the start and end. In JavaScript, it is possible to know what is the DOM element from inside the script tag. So we can use them as placeholders, so we know when fragment started, when fragment ended. And when we call start, we call require on the JavaScript, so it starts preloading. And when we call end, we basically require the very same JavaScript from the fragment, and it should expose init function that is then called with the first DOM element as an input. So this is how fragment initiates itself in the document. And async fragment is a little bit different. So instead of rendering the same markup as the regular fragment, it just puts the placeholder with an index of it in the document, and then just before the closing body tag, they are all retrieved in random order, in the order that they respond. And so pipe.end will move the content that is between start and end and into the placeholder. So the question is how do we enforce the same look and feel, because fragment, they can do like whatever they want. And for this we introduced another fragment that is inside the head section of the document. And what it has, it basically provides the global environment for each page. So it has ECMAScript 6 and fetch polyfills. It has a clean CSS environment. It uses normalized CSS to make it consistent between the browsers. And it also defines AMD modules that are common for all fragments. So such as React, our own library of UI components, translation, and event bus that fragments use to communicate between each other on the front end. So as the result, we have basically achieved SEO friendliness by merging content on the backend. We have fast time to first byte and ability to prioritize content above default. We also achieved reliability by simply not rendering the fragments that failed. So, for example, if the footer dies, you will still see the rest of the page. Or if header dies, then you will see maybe the product. So it's still some meaningful content that you can show. It's better than just failing. And we enforced the same look and feel through a set of global AMD dependencies. So each fragment has a JavaScript bundle that is an AMD module that has some dependencies on the environment of the page. And base assets simply defines these modules. So this solves part of the problem, but it doesn't solve the transition to microservices from the monolith. And Arpad will talk about transition and some more things.
Hi, my name is Arpad, and try to sum up a couple of missing things from here. One is this transition. So when we started this, we wanted to create a new, cleaner service, and we also wanted to enable other teams to work this way to implement new features in this new system, and they can practice the before mentioned autonomy. And one question was here, like we cannot plan a single big switch from the old to the new, because for many obvious reasons. It would take time to migrate everything and then wait until everything is done and then switch at one time. And it's also quite risky for lots of reasons, involving operational safety and also business impact. So what we wanted to support here was a step-by-step migration. This involves well-identifiable features, typically based on pages or built around a set of pages. And also we have this chance that don't migrate for every country at the same time. We try something in some of the countries. Actually, this checkout page that we seen before was first tried in Poland, and two beautiful red fedora hats were sold here, and that was the first sold items with this new infrastructure. And in addition to the step-by-step migration, even inside the features, for the same reasons, it would be also nice to support gradual ramp-up, like trying out first only 5% of the traffic in this given country for this given fragment. Let's see how. Before we see how. There were, in addition to these, some other infrastructure duties. One of them was combining the old and new solutions for rather less exciting features, but for things that are still required in a website. Like this means when we are jumping as a user from a page coming from a completely new system to an old one and then back again, we have to make sure that the given user session is the same, which can come with some things, but then if we are building a new system, we also want to take the chance and make the session solution a bit nicer, and plenty of similar little system features are in a similar situation. To make this transparent for the other system components, this also had to be taken care of. And in addition to all these, so this part it was rather only about the transition. This infrastructure with the tailor that Andrey just presented, and with some AJAX calls and some other services in the back, we kind of have to map a single website that is this is a single website to the outside world, to our internal services that with time the number is just growing and growing, and these come with some features. And to support this, we kind of created our own router. It started with a very small and simple requirements. Basically, we wanted to identify routes, by what we mean that a route is where a request comes in. We check what is this request, and we know which backend service to send it, or if the new feature is not yet implemented, then just send it to the old shop or Jimmy, how we call this, how we called our monolith. And another feature to fulfill these previous requirements was planned to be done by conditioning the requests and responses, meaning setting some headers, setting some cookies, modifying some paths. For example, we will see some examples. How does it do it? Here's a schematic definition of two routes. To represent the new system, we have this Acme shoes, which points to Taylor, and then we know that Taylor will serve the content for requests that come to this path. This is a very simplified scenario, and everything else goes to Jimmy, to the old system. We need a bit more of that. We mentioned this gradual ramp up. So what we implemented here was that we could specify that for this new system, only some percentage of the requests are going for now, and if it works well, then let's step it up. Other than that, every other request goes to the old system. We also mentioned this making the operation of two quite different systems smooth and transparent, and work them together. So I mentioned this example with the session. To represent this in a simplified way, I introduced here this customer cookie thing. We call it filter, and in our router, a filter is a thing that can modify requests and send them to the right backend service, and modify the responses if it has to, both or either or none. It depends on the implementation of every individual filter. By the way, these things that 30% of this pass has the name predicates. One more thing that I mentioned before, that were the requirements here, was to basically map the single public website to our internal services. As an example here, we have a post request to the search endpoint, and that doesn't go to Taylor, but it goes to a microservice, because a post request doesn't need to have any content returned, it's a better practice to rather return with a redirect, so it can be a separate route. While the ACME issues and the the Jimmy route, the catch-all route to the old system is still there. One new thing on this routing table is something like Zalando stuff. And it's only there in the two new routes, the ACME issues and the search. This covers things that kind of enforce our protocol for this new system. This means that Taylor needs to know, or better to say, a fragment behind Taylor needs to know what is the current language that the user is using, so to return the page in the right language. Just an example. Or in some cases, actually needs to know the original URL, but by default, the service by the promise just wants to serve some content on their own URL, and they can decide where to serve it, and then Taylor will be configured in the template where that is. So out of the tens of thousands of different URLs out there, they can still land in the service, and by different rules can be decided what is the actual content to be served. So all these little conversions are enforced by this protocol, our architecture's Mosaic's protocol, and converted it for the backend in such little filters. One more thing that is very similar is the template pass. I just put it there to be more precise. Taylor identifies the right template by a template pass, and the route can be associated with a given template this way. Now, this is just only the title changed. One interesting thing here that while we were working on the system, and we already had the initial implementations, these routing tables were, of course, obviously in JSON, because whenever we need to parse something, JSON is a ready given format. But we noticed on ourselves that whenever we were trying to explain something, how this given routing works, what it should do, what is broken, whatever, we typically drew on the whiteboards in this style. So we figured how nice it would be. Maybe it would be worth to try to parse it, and this is what happened from it. It's a kind of like a declarative language that looks familiar, and it's easy to understand. We believe it's called ASCII, and this is exactly the same thing that we saw on the previous slide, but in a well parsable way. And turned out that it's actually really quite easy to understand. Now we are using it with many teams, and there were never any problems to explain what this means. It worked out surprisingly good. So in one way, we could say that Skipper is a runtime for ASCII, like the router is the runtime for this language. It's not, but in a way, it's almost. When I get to the configuration part, maybe we will see more why. Those statements about the language stand. It helps team working. It's kind of self-documenting, so you can share the information about the configuration in its own format. It helps with reviews. It has syntax check, and you can even store it in GitHub or wherever. So as a next topic, we had to scale this routing table because we have really a lot of promotion pages coming from CMS services, not even a single one, and these CMS pages are turned on, off, and defined, and they typically want to catch specific paths of the specific URLs because of it has to match a brand or something, and this happens in short campaigns or long-term campaigns, and the maintenance of it is really sometimes can be really hectic. Another reason for scaling, that currently we are using this system with 15 teams, and it was already mentioned that in the future we want to use it with 200 teams. Probably that's an overestimation, but the point is that we want to use it with a lot of teams. So with this continuously changing configuration and with lots of teams accessing it, the configuration became an interesting topic. Basically, the goal was that it was impossible to configure something and then restart, or configure something and then replace. It had to happen without any downtime. etcd and some other services, some of you may know it, are created just for this, and they are awesome. They are really nice services. It's just it's not. They don't know us, so they don't know our organizational structure. They don't know our teams. One trivial problem that some team can shadow some other team's route without them knowing it, so the customers won't see a feature suddenly, and this should be prevented. So we also created an API for this. The point here is to support our organizational structure, use our otherwise given OAuth2-based rights management system, and provide a REST API and supplementary tooling for the teams to automate their own processes. Yeah, just some quick bonus. This modularity of Skipper with the predicates and the filters turned out to be useful also in other scenarios, and it's kind of easy with the current state of it to create some alternative different use cases. Here listed a couple of them. Don't use the static file server for large scale, because there are better ones, but when it is something about that resembles a functionality of a reverse proxy with some additional features like authentication, compression, or some throttling for network throttling for diagnostics or anything, caching is on its way. It worth giving a try. The open source version is quite generically written. Yeah, I'm already was advertising this page. So the buzzword would be here to, it's kind of open for individual creativity. I recommend it to try. Everything on this slide was already addressed. So let's see let's sum up what we presented here. Our architecture Mosaic because of the composition of the fragments. So more or less you can see how it works on this diagram. Let me recap it very quickly. When a customer uses their browser to see our pages, they see a single thing, and all these requests go through the router. The router knows when to send the request to the old solution or to the new one. We see two arrows, one shot going to tailor. This is where we are composing pages. It's important to mention the other one going behind, kind of like APIs for the front end. This can be AJAX requests or direct post requests or things that don't need content. The router takes the routing with this from this configuration, the layout service from a separate one. These provide APIs for the internal systems, and the teams are responsible for the fragments that are building blocks and are referenced from the templates on about this height on the picture. These fragments are served by the microservices, which part of them are the front-end microservices serving the markup, or they can just serve some other responses if it's only about some AJAX calls. And then behind them all, this small database layer, but it's actually the whole Zalando infrastructure. To see how our original goal was here solved, I may step back to the previous slide a bit, but this is where we started. We wanted to allow teams to decide on their processes, on their technology, and on their deployment and operation. Here, the teams represented on these services serving the fragments, and how it works with possibly minimal constraints. They maintain their microservices just like as if it was a backend API with some JSON responses. To see how they own their processes, a team doesn't have to depend on other teams with some deployment schedule or release planning or something like this. They can define a feature, they can design it, implement it, deploy it, and move on to the next. If they stay backwards compatible or they don't depend on other features, then this is as straightforward. I guess this is it. And finally, these are some links that we offer. We will also share the presentation. And thank you for your patience. Does anyone have any questions related to this?
Does your developers work with the whole context, or did you manage to exclude the modules to work with? I mean, while developing, they need to use the whole context. I mean, the web page, the other services, other teams work, or can you just work with the single module?
So maybe we missed the part what the team is like. So we have teams like checkout team that is responsible for the checkout flow. We have catalog team that is responsible for the catalog. We have product presentation team that is responsible for the product. So for example, if you see the page where there is a header and a footer, they may come from the catalog team, and the cart or the checkout flow comes from the checkout team. So they are almost isolated from each other. And what they are using, they're using the shared set of UI components to implement their interfaces. So we have like grid buttons, like spacers, typography, all this kind of stuff that is shared set of, it's like a library that you import and then you build your interface using it. Because all the interfaces, they have a lot of business logic in them. So the checkout flow is pretty complicated a Redux application. I mean, the new one.
Thank you.
Was this answer your question? What do you mean by context?
I mean, whole product. I mean, can you just, because a lot of teams does a lot of work, so do they need to display the whole product as a point of user view? If you are developing, you're using the whole context, the work of other teams, or can you just display your part in this project?
Okay.
Can you develop your part in the project separately?
Okay, so this was actually an answer to that. Just like, let me maybe rephrase it in a way. They can. So let's stick to a simpler example. There can be a team who is responsible to display the product details themselves, and this can, by default, it can depend only some microservice in the back that knows that this product detail data and these images belong to this given identifier of the given article. But to make the page richer, depending on the product decisions, you may want to show their recommendations, and some other team is responsible for it. You may want to show their whatever else. And once you are on a product detail page and you are an e-commerce website, a maintainer, you definitely want to put there a button to put it in the cart. And that's some other team is responsible for that. So there are dependencies. And the context is given. The context is all these teams involved, their services involved know that what is the current context, and they can interact with each other in different ways. So, for example, the one microservice can call the other for some data. Currently, we kind of discourage to embed HTML content from another front-end microservice to another front-end microservice and try to rather compose it in a single place. But maybe even that is possible. Nobody prevents it. And finally, in the browser, they are still kind of like microservices. We strongly discourage to share code between them, and we rather support these microservices, these front-end fragments to communicate with each other through an event bus. Where a simpler API can be defined and it can be kept backwards compatible much easier. So, for example, clicking on a buy button and putting it in the cart can happen through an event bus.
Thank you very much.
I would like to add a bit to this. So, teams can also create a template, so they are creating the templates. So if PDP wants to go live with their new fragment, they create a template and they set the route for themselves. So they create a template, then they add other fragments from other teams into the fragment along with their own fragment. So this is how maybe we didn't mention it.
Hi, I have a question about that Tyler and fragments thing. It looks very similar to edge side includes. Why didn't you just use varnish, for example?
Because Taylor also does some assembly, something on the front end, so it both works on the back end and on the front end. So we need to know how page is assembled in the browser. So for example, there were some issues regarding the tracking. So what we had was the tracking fragment, and the tracking fragment was above all of the fragments, and there was a tracking, a Google Tag Manager that injects all tracking pixels into the page. And it does so while the page is still being loaded. So it just uses document body append child and adds more scripts or images or whatever and this was not working with the whole thing. So what we did, Taylor also allows to just set some tags on the page to be processed differently. And instead of rendering the body tag, we render body tag open div. And instead of closing body, we render closing div and closing body. So we have like our safe playground inside the page where we can safely assemble everything, and all the tracking stuff goes like outside of it. And there also were some kind of things like, for example, HTML language. So a language attribute for HTML. So what we do, we just get accept language header that Skipper normalizes based on the domain. And then based on that, we set a length attribute of the HTML. So there is some custom logic happening there too.
Any more questions? I wanted to ask you now, who is managing performance? Who is responsible for performance of overall site? And this is what we are struggling right now with.
We don't know. So, you mentioned something, SRE, and this is also an interesting common point. I don't know details too much about it, but this is something that we are also kind of introducing now. Pilots are running in this regard, and these efforts should address performance. Right now, we are sharing common measures. Like we are running these parts of the infrastructure. A team is dedicated for that. They are responsible for the performance of their own components, and they also can give information about how certain fragments perform, what given numbers, what impact these given numbers may have for the total user experience. But other than that, everybody just tries to serve it as fast as possible without a more professional approach.
Okay. Yeah, just look at our sites, yours and ours, and pretty much the same in terms of that can be done a lot of improvement in terms of our site speed. And a lot of CSS files in the header, JS files in the header, and rendering starts after 4 or 5 seconds. That's why I was asking, because we are struggling with it right now and trying to cope with it.
So I can add to this. So because we have centralized assembly point where all the fragments come, we measure all the metrics from response times of each fragment. We have it on our dashboard, so we can see that on this page art took this amount of time and so on.
Okay.
We can also enforce this by setting the timeout attribute on the fragment. So if we know that this fragment is not important, like tracking, for example, we set like 200 milliseconds. If it doesn't respond, it's not displayed, it's ignored.
Okay.
Another thing that we are doing is also using, I think, window performance API, so to measure how much time the fragment took to initialize on the front end.
Is this software that you are using for monitoring open source, or is it your internal?
We are using AppDynamics, I think.
AppDynamics.
Yes.
Okay.
AppDynamics, and then we have Zmon. Right.
Yes.
Ah, yeah. Okay. Any more questions? No. Before we start pizza. So anyway, if there are no more questions, guys will be here. Pizza is over there, I think. We still have some time, for pizza and for chatting and discussing. Thank you all for coming. We didn't expect, on the first event to have over 100 people. I'm surprised. Hope to see you soon. Probably we'll have a next meetup in a month and a half, somewhere around half of November. And that's it. Thank you guys for coming, comparing to us.
Druga prezentacja.